Hello everybody, this is Mrs. Lindsay. Today we're going to talk about transformations. Okay, what is a transformation? First of all, it's a process which changes the position and possibly the size and orientation of a shape. There are four types of transformations. Okay, we're first going to talk about reflections. Okay, so a reflection is a transformation that uses a line like a mirror to reflect an image over that line. That line is called a line of reflection. Okay, a reflection in a line M maps every point onto in the plane to a point P prime. Okay, so again, so if this is our line of reflection right here, we are reflecting this over P onto P prime. Again, notice it's perpendicular and it's also congruent, okay, which is what this is really saying here. P is not on M, then M is the perpendicular bisector of P prime. So again, it bisects and it's perpendicular. If P is on M, then P is equivalent to P prime, which is the second diagram right here. So if the line of reflection goes through P, it would basically reflect upon itself. Okay. So a couple core concepts here. This you're definitely going to want to know here. So if AB is an ordered pair, it's reflected over the x-axis, then the new image would be A negative B. Over the y-axis, now your x value becomes negative and B stays the same. Then we have it where it reflects over a line. So if it reflects over x, you switch the x and y. If it reflects over negative x, the line negative x, then you not only switch x and y, but then you also negate it. Okay, so it's really important coordinate rules for reflections there. Okay, so whenever we're doing any of these reflection problems, you need to be able to do two things. Not only graph it, but also state what these ordered pairs are of the new image points. Okay. So if I'm reflecting this over the y-axis, again, if you recall, some of this, it's, again, if you think about it, this is going to be your line of reflection right here, the y-axis. So again, you can think about this distance, that perpendicular distance is going to be congruent. So in some cases, it might just be easier to kind of visually take a look at it. So this A would now become A prime here. And then take a look at the ordered pairs. So that would become negative 2, 2. Sorry, that doesn't look like a very good negative 2. But in other instances, it might be a little bit easier or helpful to know, again, you take the x and simply negate it, right? So I could go through and do this process and say, okay, yes, this is going to be negative 4, negative 2. So then I can come over here and graph that. And I'm sorry, I forgot on A, this shouldn't have changed. I apologize. That should have been a negative there. So again, I negate the x, leave the y, negate the x, leave the y. So again, you could visually think about it, or again, you can think about it in terms of negating that x value there. So let me go ahead and label. This is also a very important part. Please make sure you label. I need to see which point is which. Okay, so again, not only are you able to graph it, you're able to write the ordered pairs, and then you need to label these. So is this A prime or is this A prime? Which one is which? Okay, so again, this would be negating your x's, leaving your y coordinates. So let's take this line, AB, or actually it's a segment, I should say, and reflect it over the line y equals x. Okay, so this is called your line of reflection here, negative x. Line of reflection. Okay, so again, we can go back and think about what we would need to do with those, and hopefully remember you're going to switch your x and y and then negate them. Okay, so again, might be something helpful to think about here when you're writing these. Now, in the previous problem, I helped you out a little bit. I gave you the ordered pairs. In this instance here, I did not give you the ordered pairs, so we'll start with writing the original. So I have 1, 4, and then I have 5, 4. So if we want to apply this, A prime becomes, again, switch X and Y, negate them. So -4, -1. Same thing with your B prime, switch X and Y, and then negate them. So I'll have -4, -1. And the next one I think is going to go off the graph. -4, yes, it's going to go down. Let me just extend this just a little bit. Go down a couple points there. So that'd be -4, -5. And that is my B prime. So again, be able to graph, write the ordered pairs. And again, make sure you must label your graph with what point is what. Okay? And it should look like it's a reflection over the line y equals -x. Okay? Just like this should look like a reflection that it's over the y-axis. Okay? All right. I would like you to actually try this one on your own. This one will reflect over the x-axis. Might be helpful to go back and look at those coordinate rules. And again, draw it, find your ordered pairs, and make sure you label as well. Okay? When you're ready, push play to check your answers. Okay? So again, reflection over this line, y equals 0, right? Which would also simply just be the x-axis. So reflecting that, switching, negating the y, but leaving x and y. Okay? All right. So let's talk here about a triangle. So this one, they didn't actually give you the original image. So let's just go ahead and graph that first. We have triangle ABC with vertices 1, 3, 5, 2, and then 2, 1. So A, then B, then C. It's a B there. And there's my original triangle. Okay. I'm going to go ahead and just write those ordered pairs down, just so when we then do the transformation, we can adjust those as needed. So we graph the triangle. Now we want to graph its image after it's reflected over the line y equals 3. Okay, so let's actually graph y equals 3. So 1, 2, 3. That is my line of reflection. So I'm just going to draw it as a dotted line there. Okay. And we want to think about how do we actually reflect it over that? How do we do an image and reflect it over that? Well, hopefully you see here, A is actually on the line of reflection. So A prime is that one special case where it doesn't change at all. So this is also going to be A prime. Okay. So now I need to see this distance here. This is going to go up 2, because again, remember, it's the perpendicular bisector, so the distance should be the same away from the line of reflection. It's going to be C prime. And then, again, it should be perpendicular through this red line of reflection, and it is. Okay? So again, this is going to be 1 unit away, above. So that would be B prime. And now I can connect, connect, and connect. So now I'm simply going to count, right? So B is going to be 5, 4, or I should say B prime. And then C prime will be 2, 5. Okay. All right, a glide reflection. It's a transformation involving a translation followed by a reflection. So again, a translation is moving it up, down, right, or left. And then a reflection is, again, reflecting over the x-axis, the y-axis, or a line. Okay? So the first thing you want to do, obviously, is the translation. Then you can do your reflection. Now, you can do this in 2 steps, or you can do this in 1 step. Still, the process is the same. Be able to write the ordered pairs, and then also be able to graph it and label your points. You must label your points if we ask you to graph it. Okay, so do me a favor on this one. Go ahead and pause it, graph the original graph, write these out, these order pairs, and then when you're ready to do the glide reflection, push play to proceed. Okay, so the first thing we're going to do is the translation. Okay, so we literally are going to take all our y's, subtract 6, so in other words, that's going to move it down 6. Okay, so that would then take all of my y's and subtract 6, so this would be a prime. X's aren't going to change at all, but it'd be 2 minus 6, so that would bring that to a negative 4. Same thing here with the b's, x stays the same, subtract, so that would be negative 3, etc. But now some of you might say, well, can't I do this all at once? Because if you look at your reflection here over the y-axis, if you recall, what does that do? Well, that actually just changes your x value and leaves your y the same. Well, can we just combine these? And the answer to that is absolutely. So you could just simply say, well, sorry, I did not mean to choose that one. Take your x's, negate them, and then also subtract 6 from your y. So you could actually skip this step. We are going to call this a double prime though, because it is 2 different types of transformations here. You have a translation, then a reflection. So I'm going to negate that, and then whatever my y was is going to be the same here. B prime, so I negate the x and leave my y. But if I skip that all in general, which you can do, and again, this should be B double prime, negate my x, now take 1 and subtract 6, so that would give me negative 5. Now I can easily graph those points and this right here. So I could show it in 2 steps. I can show the translation, the reflection. In the end, we want this is our answer in blue there, because that is our glide reflection. Okay, it's the transformation, translation, and then a reflection. Okay, so I'm going to go ahead and just graph that one. So a double prime, negative 6, 1, 2, 5, 6, and then down 3, 1, 2, 3. B double prime, and then C is going to be negative 5, negative 7, negative 5. And again, notice I am labeling these, and these are double prime because we had the 2 transformations. Okay, so again, label your points, be able to graph it, also be able to list your order pairs, all 3 of those. All right, how many lines of symmetry does this triangle have? Okay, and again, you should be able to draw a line here where you fold one side of it onto the other side, and that makes lines up exactly. So hopefully you guys see that there is one just straight through that vertex there, and it would also work going through these vertices. That one's a little off. I'll fix that. See if I can get this one better. That's a little off as well. Let me adjust slightly. But this would actually have 3. There we go. A little bit closer there. So it would be 3. There we go. Okay. All right, and then our last one. You're going to a music store. Friend's going to buy crafts. So we got music store, craft store. Where should you park to minimize the distance you both walk? So I'm parking B, right? Which slot of here? I guess that's store B, store C, store A. But if we're doing these 2, hopefully you see that it's going to be this one right here in between the A and C, because that's going to give us an equal distance in between the 2. Okay? And again, thinking about symmetry just there a little bit. All right, so this concludes our notes on reflections.